Well, hello everyone. Thanks for joining us today. So Grantek just launched a new series of webinars called Beyond Compliance, and it's a series that talks about topics that are typically driven by regulations, industry standards, and other standards, which means that what's mostly talked about is how to be compliant. But this series goal is to take a different approach and take those very same topics and show how, when embraced differently, they can lead to more world-class operations. So one of our topics is safety, and this presentation is specifically focused on the costs associated with safety, or more specifically, the cost you can save by integrating safety into your automation strategy. It's an entirely different way of thinking about safety, taking us away from only focusing on mitigating hazards and avoiding risks, which is we're doing it because we have to mentality, instead looking at how we can save money and actually increase productivity, capability, and yet still mitigate hazards and reduce risks through an integrated approach. So we're really talking about going beyond compliance. So a little bit about me. My name is Jeff Winter, and I'll be your presenter. I'm the director of Grantek Safety Practice, which means that my main emphasis is on ensuring that all of our solutions we provide our customers are not only safe and compliant, but that safety really is an included and integrated part of how we approach and engage all of our customers' projects, ultimately trying to increase both safety and productivity simultaneously. My background, as you can see here, has me quite involved with a lot of different aspects of machinery safety, mainly focused on being an expert on what is considered correct or what is considered required, especially from a regulatory and liability standpoint. But today we aren't going to be talking about that stuff. We're going to be sharing Grantek's experience in being both an automation and a safety solution provider to help highlight what we've discovered and how you can ultimately benefit from it. So as part of this, here's what we plan on talking about today. Trends in machine safety, so you know the direction where things are headed, the savings considerations you should be aware from a capital project standpoint and an engineering standpoint, and how both of these considerations help play into operational savings. And at the end, we'll go over some ideas for how you can move forward. Now, we will publish this webinar at the end of or on our website, and after we're done, all the attendees will be emailed a link to the recording, but because of that, everyone's line will be muted throughout the entire presentation. Therefore, if you have any questions throughout the presentation, you'll need to email me directly. At the end of the presentation, I will address all the questions that have been sent to me. This helps keep everything running smoothly. So my email here on the screen is jeff.winter@grantek.com, and it'll be posted on a couple of the slides throughout the presentation. So I think a great place to get started is on the basic question of why do people invest in safety? Well, there's a lot of reasons, and looking at the list here, they all can seem kind of obvious and straightforward. The older mentality is that investing in safety is a risk avoidance measure. Companies want to reduce the chance of injuries and reduce the cost associated with those injuries and avoid fines. This is not a bad reason to invest in safety. However, looking at it through the lens of injury and cost avoidance can limit your way of thinking, and you're always kind of on the defensive side instead of the proactive side. And our experience has shown that world-class safety programs don't really look at safety that way. They view it as a great investment, a net positive, not a necessary evil. So going beyond compliance can help in any one of these areas that are listed on the screen here, but today we're only going to be talking about reducing costs. And that category in itself can be quite large and quite vague. So to narrow it down even further, we are only going to be talking about reducing cost from a capital expense standpoint. And that is probably something you haven't entertained and considered before. But before jumping into the financial benefits of integrating safety, we need to have an understanding of the history of safeguarding technology and how that is shaping our purchasing decisions in the future. So OSHA was established in 1970, and since then the dawn of machine safety really took hold. Now at the beginning, we were in an era I like to call preventing access. Your only options really were physical guards that prevented you from being near hazards. This basically meant adding metal to the outside of machines. The result? Things got safer, but productivity kind of took a hit. Then the era of detecting access started to emerge once we added control circuitry into the mix. Now you have the devices that are capable of very reliably detecting you entering an area you shouldn't be entering, or detecting you inside an area that you shouldn't be inside. There are now tons of devices in this category, most of the stuff your favorite vendor sells. These devices would just tie into your main power or energy sources, and when activated, they just shut everything off. Now, this had a huge impact in productivity, especially when you compare it to metal guards that prevent access. Therefore, it's pretty widely accepted. Then, more abruptly, really due to some standard changes and regulatory changes in Europe, we started to enter the era I like to call controlling access. Now we add advanced logic controllers into the mix and devices that are capable of automatically changing their safety parameters on the fly. Think like three-dimensional vision systems and smart safety systems that know when to turn on your safety devices and when to turn them off, depending on what is happening in your machine. It's really cool stuff. I mean, your safety and your access to your machine are now intelligently monitored and controlled. But the only way for this really to happen is to have your safety and your machine control systems working hand in hand as kind of one integrated system. So as we start to enter into the era of controlling access, we start to see a few trends take place. The first trend we're seeing is the physical hardware of safety components starting to be combined with regular automation components. Not too long ago, all your automation components and all your safety components were physically separate devices. You had your stuff that controlled your machine, and you had your stuff that made it safe. In fact, safety devices were usually brightly colored to even make it obvious that they were indeed separate components. Sometimes the safety controls would even reside in completely different control panels, separating out the components even further. So what is happening? Well, technology has advanced and manufacturers have realized it's actually less expensive to just make safety an option built into their regular automation components as opposed to having a whole separate device. So now you have safety being built into your logic devices, built into your motion control, built into your fluid power systems, and even built into some of your detection devices. If you look at the big boys out there, let's say, for example, Rockwell Automation, they've even said that their roadmap is really to only have one PLC in the future. They won't have a dedicated safety controller and a dedicated regular machine controller. They'll just have one controller that does both. From a hardware perspective, that's great. Less hardware means less cost, less spare parts, even smaller control panels. Now, most new machines today are being built with this new hardware that has safety as an option, honestly, just because it's cheaper from a hardware perspective. But the safety may not be being used in those cases. It may just be there and potentially even being wasted. So chances are you're getting some of this stuff and you may or may not be realizing it, or may not be taking advantage of it. So the next trend is similar to the last, but with a different twist. It used to be that machine control systems were completely independent of safety control systems. We're not just talking about the devices now, we're talking about the brains, the decision makers. The machine control made sure that the machine did exactly what it was supposed to do, and the safety control did nothing but just make sure the safety devices were working and could shut down the machine in the event of an emergency or a failure. In fact, a lot of machines were designed to where the two systems never talk to one another. So if your safety system tripped, your machine control wouldn't even have any idea what just happened. Now, is that bad? Well, it doesn't necessarily make the machine less safe at all, but it does sure make troubleshooting a nightmare. So not only is the hardware consolidating, like I showed you on the last slide, but the platforms and control architectures are integrating together. You now have safety logic incorporated into machine control logic. You even have networks that can transmit both regular and safety data. So what does this get you? Well, it sure simplifies wiring a lot and simplifies design, which reduces cost and complexity. But it also allows for much more access to information on what your systems are doing. Now, for the first time, your machine control knows everything that is going on in your safety system. Why? Well, they're integrated together and are no longer separate. And when your machine control is integrated with your safety control, a lot of possibilities open up, especially in terms of productivity. So let's combine the two trends and show you how two different safety functions, what they look like. So the conventional way with discrete components, and we'll talk about the wave of the future, I like to call it, which is the integrated components. So the conventional safety function shows single-purpose devices all connected together. I mean, this example here, you have a light curtain being plugged into a safety monitoring relay, being plugged into a safety contactor. It's a fairly simple safety function. You break the light curtain, power is shut off on the machine. That's it. That's all it does. You can't even screw it up. If you want a different function, you have to go buy different devices. I mean, that's why they're called single-purpose safety devices. They serve only one purpose. Now, in the bottom, you have a more advanced safety function. You have controlled access devices alongside configurable devices. These then run into a safety logic controller and then into safe motion components. Now, you have many options on the input side to program the device to be very picky in what and when it detects something. And that then goes into the programmable controller, where the sky's the limit in your ability to devise specific logic that works for your application. I mean, you can set up sequencing or conditions and even automatic decision making. And then on the output side, you're no longer just restricted to the old thought process of killing power. Now you have a whole new slew of options for what you can do instead. I mean, you can now safely control speed, direction, you can control acceleration, torque, range of motion, and even safely pause the machine. That's a lot of cool things you can do now instead of just killing power. So as you can see, the possibilities here really can now be endless with the wave of the future or the integrated solutions. There are huge opportunities to make improvements in both safety and productivity at the same time. So why is this important right now? Why 2017? Well, there's two main drivers that I've noticed from my experience. One is you now have industry best practice standards backing and supporting the technology. I mean, take safety PLCs for an example. They've been around for over a decade, but standards to support them have only really recently come out. And that gives everyone, whether it's a customer, whether it's an integrator, a machine builder, confidence that they're in fact providing a safe machine and a safe work environment. The other reason is reduced hardware costs. Simply put, integrated safety has gotten a heck of a lot cheaper than it used to be several years ago. So these two main reasons are why this is really a big deal right now. So does this mean you should go out and rush and replace everything with the newest technology? Probably not. Find out what works best for your company. Now, if you look back, let's just say roughly to the year 2000, most companies gravitated towards simple safety solutions, where today most companies are starting to look at those advanced integrated solutions. So why the shift? Well, it's really two aspects. Closer to the year 2000, the ROI and even the risk mitigation itself, it kind of pushed people more towards the simpler solutions. It just wasn't really worth it to use the more advanced stuff. Too expensive and not fully accepted in the industry yet. However, today, the shift in ROI is actually pushing more people to advanced solutions. Stuff has just become less expensive, and now you have a lot more backing by industry standards. So companies are starting to use it, even if they aren't taking advantage of everything it can do. So figure out what makes sense for your company. Going 100% to the advanced solutions across the board on all pieces of equipment right away may not make the best sense for you right now. Maybe it's only certain machines, certain facilities, or just certain departments. Where most companies are embracing this new technology right away is, though, on new machines and where they have large capital projects. It just makes financial sense for those types of things. So we think that this is a good segue now to start to talk about the savings considerations that you can have from a capital project standpoint. Most companies, they have separate projects for safety upgrades and for controls and automation upgrades, usually because these projects are funded under different budgets. I I mean, I would venture to say that this is because safety used to be thought of, like I showed you before, just guarding. And therefore, most people view it as it really has nothing to do with controls or automation. At least that's the heritage of how it came to be. But hopefully, as you saw in the trends, safety and automation they're blending together. And therefore, the projects start to become blended together. So if you keep your projects separate, then as this blending starts to continue, you're going to end up spending more money in the long run. Now, some of you may be thinking, oh, come on, Jeff. I mean, we always combine these types of projects. No one separates them like this. Well, let's use Grantek as one example here. So our company has upgraded hundreds of machines from a safety perspective, and we've upgraded control systems on, oh gosh, thousands of machines in just the past 5 years. I mean, after all, we are a controls integrator. So how many times have just our customers, Grantek's customers, combined their automation and their safety projects? Probably only around 20-ish times, or about 5%. That's not a lot. So no, most of our customers are still separating out their projects. And the biggest reason I'm guessing is because they are different budgets and have different purposes. The financial impacts of not combining them are being overlooked. And really, that's why we're here today. That's why we put this together to share with everyone. So let's look at one particular case study. 2 projects, 1 customer. So in this example, customer came to us with the first project, Project 1, which had a clear mission: upgrade the safety on 2 depalletizers. Someone got hurt, we need to upgrade it right away. 6 months later, after we upgraded the safety, the customer came to us with a request for a second project on the same machines. They now had funding to upgrade their obsolete control systems and asked us, well, how much would it cost? Now, this is a perfect example of a real-world scenario of 2 projects being split because of different budgets. And so you know, the customer postponed doing Project 2, the PLC upgrade, because it cost too much. Now, in hindsight, had we all known then what we do now about the cost savings, I bet they would have done the projects at the same time. So let's dive into the details of the project. As you can see here, these are the typical areas that we break out our costs per projects, at least the major categories. So this project happened to be 2 identical depalletizers. The project included upgrading the guarding, adding safety devices, and upgrading the safety control systems, which, because they had no space in their control panel, required a secondary panel. This is actually a fairly standard safety project, and you can see here that the mechanical hardware and the electrical hardware and even the installation, they take up a bulk of the price. So upgrading the safety on these 2 machines is roughly $200,000. Now let's look at the pricing breakdown of Project 2, which, remember, was requested 6 months later, after we already upgraded the safety. So this project included replacing an old Modicon PLC with an Allen Bradley control logics and adding a panel view HMI. The cost of the upgrade, just shy of $100,000. Now, if you haven't done or haven't been a part of a PLC migration or controls upgrade project, you may be surprised at their cost. I mean, it's a lot of effort to replace the brain of your machine and to modernize it. So seeing $100,000 in this example was more than the customer expected. They didn't want to skimp or to put a Band-Aid on it, so they just decided to postpone this project. So here is a visual of the 2 projects from a controls perspective. Project 1 had a bunch of safety devices going into a safety controller, which had some basic communication with their existing Modicon PLC. Project 2, had they chosen to do it, it would have been to convert that Modicon PLC to a control logics with the addition of an HMI. So those were the 2 completely independent projects. Very typical in our industry. Like I said before, more than 95% of our projects look just like what you saw. One project to upgrade safety and a separate project at some other time to upgrade controls. Now, adding these project costs together totals just over $300,000. Now, in this first case study, we're going to be talking about the potential savings just by doing the projects at the same time. That's it. no changes in scope, no changes in hardware, no changes in functionality, the exact same solution. Just do the projects at the same time. So how did we come up with these values? Well, we created real quotes for real projects of those 2 independent projects I showed you before per the customer request. All we did is we just went back and developed a new quote, assuming that we were asked to do the project simultaneously. Now, as you can see here, there's a total savings of roughly $46,000, and that's about 15% of the total cost of both projects. However, that cost or that savings is nearly half of what the PLC project was just by itself. So just by combining them, we would have got half the PLC project paid for. That's pretty interesting. So now let's look at some of the specific areas of savings. So project management. Well, having one project, simply put, means less project management activities, less meetings, mobilization time, information gathering, scheduling, financial monitoring, and all the stuff associated with project management. Next, and the biggest percentage area of savings is the system integration, the software side. The amount of time doing code modification and code rewriting is drastically reduced, and we don't have to write code twice, essentially. We would have to write a program for the safety PLC, update the Modicon PLC, then reprogram the safety PLC and program the new PLC. So throw in all the extra debug and quality control time for both of those upgrades, you can start to see how cost is reduced by combining your projects. Now, electrical design has the biggest dollar amount of savings at nearly $18,000. Well, the safety project required modifying 12 of 15 existing drawings and actually creating 14 new drawings. The PLC project would have modified all 15 of the original drawings, plus a majority of the new drawings, and even added a couple new ones. So from an engineering standpoint, it may be good to know that creating a new drawing actually takes less time than modifying existing one. So this is where you can save a lot of money, is in the electrical design of combining your systems. So since the hardware would be identical in combining projects, there really wouldn't be much savings from an installation standpoint. Really the only thing you're saving here is a little bit of time and travel time. You only need to go on site once instead of twice. But the commissioning and the startup is actually cut by a quarter. You only have one set of acceptance testing required. That saves a lot of cost. The electrical and mechanical hardware here, remember, did not change because the solution didn't change. So in total, just by combining the timing of your projects, in this example, the customer would have saved $46,000. So now, imagine if you potentially combined more projects. Let's say, for example, servo upgrades or fluid power upgrades or other planned improvements. You can start to see that the numbers could even go up more. So now, do you think if we had these numbers at the time the customer was looking at the projects, and especially the PLC project, do you think that they would have done them both at the same time? Chances are they probably would have had they had this information. So we just showed you the savings associated with better timing of your projects. Now let's look at the savings that can be realized by re-engineering your projects. So if you're combining your projects, you have more possibilities to make design changes. So let's show you what that can look like. So once again, let's consider the problem with separating out your automation and safety projects, but this time from an engineering perspective. So this is now looking at the project from a redesign perspective. So if you're doing both projects at the same time, you have more options for simplified design and a better ability to take advantage of the built-in safety features and just newer, cooler technology. I mean, when they're separate, you usually are restricted in the technology and solutions you can use. If you just do a safety-only upgrade, you pretty much leave the control system alone. Sometimes you just give basic status information to it, but that's it. That's not an integrated system. And since it's not integrated, the project shifts towards simpler single-purpose systems, resulting in designs being the conventional way like I showed you before. A safety device is wired just right into the energy sources to shut the machine down. Now, having more advanced systems in the scenario are often overkill because they're not connected to anything related to the machine's functionality. So when doing a standalone safety project, it's kind of natural to stick towards older technology just to keep that single project, that standalone project, as cheap as possible. Now, the same thing goes for controls upgrade projects. Companies don't usually upgrade controls with features or technology that they aren't going to use. And one way they do this is kind of consider safety out of scope from a controls upgrade standpoint. So looking at this myopically, it makes sense that that one project would be cheaper because you're looking at just that one project, that one need. It's only once you look at the two projects together that you realize, wow, it costs more to do them separately. So when you're upgrading your machine controls at the same time as your safety, not only are you saving by combining projects, which we showed you, but you also open a window to reduce hardware, simplified design, simplified wiring, and being able to utilize built-in productivity enhancing features of the integrated safety technology. So let's go back to our original two projects that we showed you from before. In the second case study, we're not going to talk about the cool changes in functionality that you can get. We will only be talking about the savings associated with simplified design and how that relates to overall project costs. That's it. But keep in mind, if we were truly doing both projects simultaneously, we would absolutely suggest entirely new solutions that do take advantage of more advanced safety systems. I mean, why wouldn't we? It's already built in, and now is the time to create new functionality in how your systems work. So think about it this way. If I can show you the benefits without taking advantage of those cool new features, well, imagine the story that can be told if you actually do take advantage of them. So now, if we re-engineer the solution here, we would have no reason for a dedicated safety controller and therefore no need for a whole second control panel. We would just combine the controls, both the machine controls and the safety controls, into a single safety PLC. This simplifies the design dramatically. Again, not only does using an integrated safety solution simplify the design, which is what we're showing here, but it really does open up the possibilities for more advanced solutions. Think about like monitored entry exit into the Depalletizer cell, advanced safety data reporting, zone control, a whole bunch of things we could take advantage. But right now we're only focusing on simplified design. So we will keep the cost from our previous case study up so you can see the compounded benefits as we expand. You can see the left column is the total cost of doing both projects separately, $303,000. The next column showing how just doing the projects at the same time saves $46,000. And now we're going to see the what it saves by adding a re-engineered column, which shows the additional cost savings of the simplified design. Now, the savings in bold show the combined total savings, and the saving increases in red really just show the added savings above and beyond the combined savings. So overall here, you can see that there's an additional $14,000 in savings with simplified design alone, taking the total savings to over $60,000, or what would be about 60% of the original PLC upgrade project costs. Now, project management we assume is the same in this case. So we jump to system integration. A small bump in savings by simplified programming by not needing to do handshaking with multiple components anymore. Now let's look at the electrical design. Small bump in savings here too is no second panel needs to be developed, and because of integrated hardware, there's just less wiring diagrams to create. Now, the electrical hardware savings is probably counterintuitive. And because we all know that safety PLC does actually cost more than adding up the individual prices of a regular PLC and a dedicated separate safety controller. However, what most people don't really factor in is in all the additional costs necessary to make it work as a system. I mean, there's a lot of extra electrical hardware that's needed just to support the two controllers. In this case, the cost of the second panel and all the components necessary to be put in the panel and get it connected. So removing that stuff actually lowered the overall cost of just the hardware alone. It was a tiny bit, but it didn't increase it. It actually lowered it. Installation was a biggie. This is an additional 20% drop. Now, if you remember, this was only a minor bump when we just combined projects because the hardware didn't change in that example before. But now the hardware did change, and therefore the install time of fewer components goes way down. Less wiring can save a lot of time. And then there was also another small bump in the commissioning and startup. One controller means simpler debugging and faster acceptance testing through less I/O checks. Now, since we didn't change the functionality of the solutions, or really the solution itself, we only simplified the design, mechanical also did not change. So in total, we saved over $60,000 in this example. Now, once again, imagine if you also upgraded motors, servos, fluid powers, and other parts of the machines. Once again, these savings can really start to add up, especially if you could take advantage of re-engineering or redesigning the solution because you did them at the same time. And we aren't talking about productivity gains or decreased downtime, just the cost of the upgrade itself. So I want to switch gears to a third case study, which is an attempt at showing another way in which engineering savings can be expanded further when you're doing multiple upgrades. So this case study represents a large project we did, upgrading the safety, and only the safety, on 84 machines, which consisted of palletizers, depalletizers, and stretch wrappers throughout 9 different facilities in the country. Remember, this was only safety. No automation or controls. This was a multi-million-dollar, multi-year project. So the way I broke out these costs was different to show how having an integrated safety solution would lower the overall project cost through minimizing the costs associated with system modifications. So in the case of 84 machines, there were a total of 51 changes to safety systems. Now, this number may seem high, but it's actually about average for a project of this size spread across 9 different facilities. It's mostly driven by customers' requests to change how the safety system functions after we've already made our design or our install. So I broke this into functional changes, which, like I said, there were 51, and equipment environment changes, which there were 17. Now, equipment environment changes really include stuff that is location specific that hindered our ability to add a second panel nice and easily to the side of the machine. I mean, there were instances where there were beams in the way or cramped walkways. In fact, there was even one where just a fire extinguisher station that it needed to be moved. Now, on average, the functional changes cost around about $8,500 each. Some were higher, some were much lower. And the environmental changes were roughly about $3,000 each time they occurred. Now, when you integrate the safety solution, modifications to the functionality become easier. And once again, there's no need for a second panel. So on average, a modification functionality would go down to about $5,000 per change through more changes taking place in programming. Now, when you extrapolate that out, that's about $178,000 for this entire project. And there'd be no environmental changes, saving an additional $51,000. So now, we're not even talking about using different solutions. We're just talking about the overall cost savings of using integrated safety. In this case, a massive company-wide initiative, how many control systems could you have upgraded with an additional $250,000 in savings on this project? It's something to consider. So now we've covered 3 case studies aimed at really kind of showing capital project and engineering savings. But now I want to start to talk a little bit about the operational savings. So our 4th case study is a little different. Looking at the impact on operational downtime, a direct cost not usually factored in to upgrades. I mean, when you look at an upgrade, you usually figure out like how much money it would cost in an example like Grantek to upgrade a particular machine. But what about the downtime costs just associated with the project itself? So how does combining your projects and re-engineering your solutions help operational downtime from a project perspective? Well, let's take a look. So case study 4 happens to be another way of looking at any of the projects that we've discussed so far. Instead of looking at direct cost for the project, we are looking at an impact to the customer's production by doing the projects. So the average number of production downtime days is about 6 for a safety project, like one of the ones we showed earlier. Coming back at a later date to do a PLC upgrade, it may take up to an additional 4 days of downtime. So now we're totaling about 10 days of downtime just to do the upgrades. Now combining the project saves anywhere between 2 to 3 days of downtime. So how much does that save your company? I'm going to guess that 2 to 3 days worth of downtime could be more expensive than the whole PLC upgrade project in its entirety. So that alone may be able to be used to justify combining the projects. So now let's look at operational downtime associated with taking advantage of integrated safety with some of those more advanced safety control features. So this does assume that we are using some of the cool new technology as part of the solution. So in this example, we're still talking about a depalletizer, which from what the customer told us on the one that we upgraded, it had about 96 forklift entrances within a 24-hour shift. It was about every 15 minutes is one came. So now each time that entrance, it leads to a short amount of downtime, only seconds, but multiplied out for the entire day can really add up. Now reset times can easily be lowered on average from 15 seconds down to about 3 seconds, saving about 20 minutes per day of downtime by just having a more advanced system that has better control of how your safety and your machine control integrate together. The bigger impact here is actually going to be on the unplanned stops. These events are typically less often, but have a much bigger impact on downtime. So depending on when a depalletizer stops within its cycle can drastically impact how long it takes to restart the machine, ranging from 16 seconds or worst case up to 15 minutes. By using an integrated safety solution, you can control your shutdowns better, and we can cut that down to as low as a minute, even for the worst case scenario. The reasons I'm bringing up these solutions as having impacts is because zoning your safety systems and controlled shutdowns is actually fairly easy in an integrated solution, where it's cost prohibitive in an independent safety solution. We couldn't even really do it. Just one of the many additional benefits you get by having more control and flexibility. So now let's look at troubleshooting time. So as hopefully everyone should know, one of the things that makes a safety system unique is that its entire purpose is basically to shut down a machine and not let it run until a problem is fixed. Its whole purpose is to keep that machine from running if it detects a problem. So because its very nature is to prevent a machine from running, figuring out problems quickly can have a big impact on downtime as well. In the case of operators, they are the first line of defense to troubleshooting any problem. Because independent safety systems don't really have much available diagnostic capabilities, it can be harder to determine the culprit of something going wrong. With a separate safety system, you most likely just have a system fault light, and that's it. Go figure it out. Now, integrated safety has all of the diagnostic information just built right in, telling you the status of everything going on, every fault code. So this info can easily be displayed right on an HMI. If a fault code is displayed in this manner, troubleshooting time by the operator can, in theory, be reduced to 0. They know what the problem is right away. Now, technical troubleshooting time is meant to represent anything outside the expectations of an operator making a simple fix. In this case, we use times which reflect our Grantek engineers, qualified professionals who understand the system. So arguably, these numbers actually could go way up if you have an unqualified staff or someone who doesn't really understand the technology of the machine. So in addition to more diagnostic information being available in an integrated safety solution, there are just fewer systems to evaluate. I mean, even if you have to connect your computer, you only need to connect your computer to one controller, as opposed to having to connect to 2 different controllers and potentially looking at the differences between what's going on between them. You have one controller that's doing both your safety and your machine control. So overall, case study 4 is meant to kind of inspire you on different ways that you can look at improving your downtime, which in turn improves your profit as a company. So we've touched on several different considerations here for savings today. And hopefully our case studies were able to easily highlight areas where you might want to pay attention to within your organization to get the biggest bang for your buck in your future projects. So combining and re-engineering your automation and safety projects, it won't guarantee you savings. I mean, there's always exceptions to every case, but more often than not, there will be incredible savings if you pay attention early on and plan your projects effectively. I mean, the savings can even go up a lot higher than what we showed you here. That just happened to be real-world projects that we had. Now, I'm not saying that every project should both be safety and automation at the same time, every time, but you really should be considering both every time. Every time you have a safety project, consider the potential savings if you upgraded parts or all of your automation or your control system. Every time you have an automation or controls related project, you should consider upgrading the safety. Like I said, more often than not, it will be a no-brainer to do both at the same time. You just need to think differently as you look at it. Also, remember that when you decide to combine the projects, you open up the capabilities of your safety system, and most of these new capabilities can additionally help drive increased productivity, which in most cases can help justify the cost of doing the upgrade to begin with. So a few things to consider moving forward. Does your company have any planned safeguarding upgrade projects in the next 5 years? If you have any upgrades that you're looking at, once again, you may want to consider looking at the control system at the same time, not only from a cost perspective, but also finding out what else it can do from a productivity standpoint. On the flip side, does your company have any automation related upgrades in the next 5 years? Especially obsolescence planning. Most companies are planning for older equipment that is out of service, no longer warranted, and if it fails, your whole thing is down. So they're planning to replace those. Well, if you're planning to replace your control systems or your motion control, your servos, you might want to look at going, should we be doing safety potentially at the same time here? Have you looked into how safe automation technology can improve your productivity, or even arguably your safety? Chances are you can improve your productivity through these new safety systems, not just the cost of the project, but actually improve your day-to-day productivity. And are your engineering and safety equipment specifications updated to take advantage of new safety automation technology? Because chances are, if you hire a company like Grantek or one of your favorite machine builders, they're going to be using some of the safety stuff from a hardware perspective anyways, just because it may be cheaper from a hardware perspective. And everyone just may not be taking advantage of it. So look to see if your engineering and safety specifications are actually taking advantage of this. So if you guys want more information on this, this case study was simplified And actually it was submitted to Control Engineering and it was posted in their magazine. So you can have a more eloquently worded version that we do have. And we will give a direct link to the magazine article if you want to see how all these kind of cost savings came in. I went into more detail today talking about it, but this is a published article that people can take advantage of. So with that being said, I was exactly at 45 minutes and I wanted to see if anyone had any questions to come up with. Remember, you email me your questions and I will answer them. So far, it doesn't look like we have any, which hopefully that means I just did a great job of explaining it. We appreciate your time today. Thank you.